Hello, Professor. My name is Davidson Tandanu with student ID 108990015 from IES department. And in this video, I want to present you an interesting topic that I learned, which is convolutional neural network. And in this video, I also will explain why it is different when we compare to classic neural network. So this is the table content of what I will present in this video, which are brief introduction of the topic, explanation of neural network and how it works, and also explanation of CNN and how it works, and what is the difference between neural network and CNN, and lastly the conclusion. So here is the introduction. So let's imagine that I am traveling abroad to Russia, but since my mother tongue is Indonesian, so I cannot understand Russian. But since I have Google Translate in my smartphone, I can just point to the word that I want to translate, and the Google Translate will translate it for me. And that's a problem solved, and I can continue my traveling with ease. These are some neural network example, and Google Translate is one of the uses of the neural network, and from many uses of neural networks such as facial recognition and music composition. And neural network form the base of deep learning, which is a subfield of machine learning, where the algorithms are inspired by the structure of our human brain. And neural networks take in data and train themselves to recognize the pattern in data, and then predicts the outputs for new sets of similar data. Since we know that CNN is part of the neural network. I should first explain neural network first before we go in deeper with CNN, since CNN is part of the neural network itself. So neural network, neural network is composed of node layers, uh, such as input layers which receive the inputs, hidden layers that perform most of the computations required by the network, and also output layers that predicts the final output. It reflects the behavior of the human brain that allowing computer programs to recognize patterns and solve common problems in the fields of AI and deep learning. So here we have a neural network that differentiate between a square, circle, and triangle. And neural networks are made of layers of neurons, and these neurons are the core processing of units of the networks. Here we have an image of circle which composed of 28 by 28 pixels, which make a total of 784 pixels. And each pixels then is fed as input into each neuron of the first layer, and neurons of one layer are connected to neurons of next layer through channels. And each of the channels is assigned a numerical value known as weight, and the inputs then are multiplied to the corresponding weights, and their sum is sent as an input into the neurons in the hidden layers. And then each of these neurons is associated with a numerical value called the bias, which is then added to the input sum. This value is then passed into the threshold function called activation function. The result of the activation function determines if the particular neuron will get activated or not. And an activated neuron then will transmit its data to the neurons of next layer over the channels. So in this way, the data is propagated through the network. which is called as forward propagation. And in the output layers, neuron with the highest value activate and that determines the output, which is also the probability. But here, neuron with square has the highest probability, so it is the output predicted by the neural network. From here, we can know that our neural network has made a wrong prediction, but we have to note that the network is still yet to be trained. So during this training process, along with the input, also as the output fed to it. So the predicted output then compared against the actual output to realize the error in prediction. And the magnitude of error indicates how wrong we are in the sign suggests if our predicted values are higher or lower there than expected. The arrows here give an indication of the direction and magnitude and of change to reduce this error. So this information is then transferred backward through our network, and this is known as back propagation. Based on this information, weights are adjusted, and this cycle of forward and back propagation is iteratively performed with multiple inputs. So this process will continue until our weights are assigned, until the network can predict the shapes correctly in most of the cases. So these are some applications of neural network. For facial recognition, camera on smartphone these days can estimate the age of the person based on their features. Firstly, it will differentiating your face from background and then correlating the lines and spots on your face to a possible age. And then for the for the for forecasting, neural networks are trained to understand patterns and detect the possibility of rainfall or a rise and stock prices with high accuracy. And for music composition, neural networks can also even learn patterns and music and train itself enough to compose a fresh tune. Uh, so we're now getting into convolutional neural network. Convolutional neural network, it is an artificial neural network that has some type of specialization to pick out or detect patterns and make sense of them. This pattern detection is what makes CNN so useful for image analysis. So, CNN is actually a classic neural network, but here the hidden layers is called convolutional layers. Uh, just like any other layer, convolutional layers receive input, then transform input in some way, and then outputs the transform into the next layer. With a convolutional layer, this transforms is a convolutional operation. And with each convolutional layer, we need to specify the number of filters the layer should have. And these are distinct. Uh, to distinguish between convolutional neural network between the other neural network, such as it is used in computer vision, and it has convolutional network, and in the convolutional network, inside there's a filters. And then for the number of rows and columns in the filter can be vary and is dependent on the use case and data being processed. Within a convolutional layer, there are a number of filters that move through an image. This process is referred to as convolving, which is a term with origins in mathematics, involving the act of combining. And the filter convolves the pixels of the image, changing their values before passing the data onto the next layer in the network. as you can see here, there's it's actually the same with neural network, but the hidden layers is convolutional network, and the inside the convolutional layer there's filters in it. So how does convolutional neural network work? So the for here we can see it's a MNIST dataset, and here we have 7, and we converted to matrix 0 0 like this, and then the filters will move, or here is convolves through each 3 by 3 matrix of pixels until all the pixels have been covered, and the dot product of each calculation is then used as input for the next layer. And initially, the values in the filter are randomized. As a result, the first passes our convolution acts as a training phase, and the initial output isn't very useful. And after each iteration, the CNN adjusts these values automatically using a loss function. As the training progresses, the CNN continuously adjusts the filters, and by doing so, it is able to distinguish edges, curves, textures, and more patterns and features of the image. So, but as you can here, we convolve from 3 by 3 matrix to the right side, and then after go through the right side, we go down side, and then on and on until we can get a smaller set. And but yeah, in order to implement a loss function, a CNN needs to be given examples of correct output in the form of labeled training data. And typically CNNs benefits from transfer learning, which is a practice that involves amassing knowledge about a problem and applying it to similar cases in the future. When transfer learning cannot be applied, many convolutional neural networks require exorbitant amounts of labeled data. Here, now we go through the difference between CNN and neural network. So, what is the difference between CNN and neural network? It is actually, the reason is because CNN do much better than classic neural network on images and videos, because the convolutional layers take advantage of inherent properties of images. And for the first one is convolutions, where simple neural network don't see any order in their inputs. So if you shuffle all your images in the same way, the neural network, you will have the very same performance it had when trained on not shuffled images. And CNN also take advantage of local spatial coherence of images. It means that they are able to reduce dramatically the number of operations needed to process an image by using convolution on patches of adjacent pixels, because adjacent pixels together are meaningful. And the second one is pooling layers. So the pooling layers, we can downscale the image. This is possible because we retain throughout the network, and features that are organized spatially like an image. So the downscaling them makes sense as reducing the size of the image. But on classic neural networks, inputs, you cannot don't scale factors, so there's no coherence between an input and the one next to it. So the conclusion that I get from what I learned, so is the main difference between CNN and neural network is that CNN use convolution operation to process the data, and which has some benefits for working with images. So in that way, CNNs reduce the number of parameters in the network. Also, convolution layers consider that context in the local neighborhood of the input data and constructs features from that neighborhood. And I think that's all. Thank you, Professor.